Now we have our grid, which is generated via the parameter t, and we want to be able to rotate this grid in 3 dimensions but map it onto our 2D space. Now we already know how to do that because we've derived the equations for it, and I've repeated the equations here. And note you only have an equation for an output x and an output y. You don't have an output z because we don't have the z plane here. What happens is the z plane gets mapped onto the x value, and also the z plane here gets mapped onto the y value. So what we want to do is put these equations in for our rotation. Now we're going to just change the nomenclature a little bit here. We're going to have 6 equations, so we're going to have an equation for the x component of the x output, the y component of the x output, and the z component of the x output, and also the same thing for the y, the x component of the y output, the y component of the y output, and the z component of the y output. So let's say we're going to have an x, a y, and a z, and we're going to also have another x, a y, and a z. And what we'll do is we'll use the subscripts. So this is going to be the x component of the x output, the y component of the x output, and the z component of the x output. And we're going to have an x component of the y output, and y component of the y output, and a z component of the y output. And then we have to add in the actual equations, so we're just going to have equals, and all we need to do is just type in our equations. So I'll just type the first one in here, and then I'll quickly put in the rest. So the first value is going to be cos beta cos alpha. So this is going to be cos, and open brackets, beta times the value cos alpha. And you see it gives us the option of creating our alpha and beta, and we can go ahead and create those. So that's the first one in, but we need to put in the other 5. So let me go ahead and I'll do that now. So that's me added in the 6 rotation equations, which I've added into this folder here. So all I've done is just typed in what we have here. Now, if I wanted to try and rotate this now, you'll see that we've got our alpha, beta and gamma, but when we move them, nothing's going to happen because we haven't tied this here into the output equations. So right now, the output equations are just going to be given by our h of t, g of t, and g of t, h of t. So let's equate the terms here with the equations. We're going to have our rotation equations, which are our trigonometric identities, and there's 6 of these, and those are the 6 values here. This 1, 2, 3, 4, 5, and 6, and those are going to be multiplied by the input. Now the input originally was just a point, x0, y0, and z0, but now the input is going to be this grid, and the grid's going to be generated by our functions g of t and h of t. So our new inputs, which are represented by x0, y0 and z0, are actually going to be h of t and g of t. Now notice that we've actually got one missing for the moment. We don't have the one for z0, but we'll get to that in a little while. So we're only going to have the 2 inputs, h of t and g of t, and those are going to multiply the rotation matrices here, 1, 2, 3 and 4. So let's go and put those in just now. So we're going to have our x subscript x times our h of t, and we're going to have to add on our y underscore x times our g of t. So that's just going to give us 1 point, so that's the x coordinate, but we'll need to get the y coordinate. So to get the y coordinate, we're going to have to do the x subscript y this time, times the h of t, and we're going to have to add on the y subscript y times the value over g of t. Now, if that has worked out properly, so we'll get rid of this, then we should be able to see this rotating. And then you can see it rotating in all three directions. So that works. So now if we want to generate the other value, then it's quite straightforward. We can simply copy everything we have here and we'll paste it in here. But now what we're going to do is replace the h and the g, and we'll swap them round about. So that's going to be h of t is going to be g of t, and that g is going to become the value of h. And this one here, h, is going to become g, and this g is going to become h. So now we can rotate this one here about all the axes. So finally, if we add them together, we'll be able to see this grid here being rotated. Now all we've done here is rotate this grid, but we wanted to generate a 3D function. But in order to generate the 3D function, we're just going to have to add in the last part, which is the z0 and the z0 here. So in order to do that, we're going to have to generate another function for the input. So the input is going to be the value z0 here, so that's going to be generated by this new function. So let's put the new function in. So the new function is going to be f is equal f of a function x comma y is going to equal, now we'll put in, just to start off, we could put in, say, sine of x times y. So that's the new function that we're putting in. So in effect, this function here is equivalent to our other two functions, which are our grid equation. So we've got one here and we've got one here, and the final one is going to input is the f of xy, and this is the one we're going to change so that we get different 3D graphs. So now we've got this function in, we're going to have to add it into this line here. So what we're going to do is have the x and the y, and also now we're going to have to add in the z. So that's going to be plus the value over z. Now the z now is going to be a function of two variables, a function, sorry, of two functions. So the two functions are going to be the value of our g of t and our h of t, and that's times the value of our z underscore x. And we're also going to have to add it into the y component here, so we can just copy this across, Control C and Control V, and it's plus, but it's now plus the z underscore y. So that should give us our new function. So we just have to add in the fact that that's a function, and also that's the function. So you can see here we're starting to get something that looks three-dimensional already. Now we need to do the same thing for the other values. So we can copy this one here, Control C, and we can place it in here, Control V. And we can also copy this one here, Control C, and we'll place this one in here. But note, we're going to have to swap the G's and the H's here round about. So that's going to become our H, and that becomes our G, and this one here becomes our H, and this one here becomes our G. So this here should be our final function, and let's see us rotating it round about, and we'll see whether this actually is going to work. And you can see this is our function rotating round. So what we'll do is we'll slow it down a bit. So you can slow it down by changing the rotation speed here. So let's say it's ×1, I'll make it times 0.1. And again this one here, ×1, make it 0.1. I'll make this 0.1. So that's going to slow it down a little bit. Now we can also adjust the size here so it takes in a lot more coordinates, and then we can make it a little bit smaller, and we can also adjust the resolution. So that's the resolution being adjusted here, and this here is a function f of xy is equal to sine x comma y. And we can change this to any function that we want. So for example, we can try cos of x hat 2 plus y hat 2. And there's our function here. And of course, we can change the colour of the functions here simply by changing the values for our outputs. So our outputs here, if we change the colours, we can get different effects. And we can look at just one axis, and we can look at the other axis, or both of them together. So that's us generated a 3D function, and we can rotate it around all three axes, and the function gets mapped onto the 2D surface.